Hello, everyone. How's everybody doing? I hope you're doing fine. And welcome to the end of the world. Yeah, I'm going to talk a little bit about that very little tiny introduction, only because someone raised the issue in one of the comments. But before I do so, let me tell you some of my intuitive reasons for why I think it's the end of the world, okay? Or we're close to it, okay? Whatever close means to you. Okay, and here's a synthesis of some of the intuitive things that I see. Maybe you have a different intuition. Okay, fine. I can only give you mine. And here we have him. We have Mr. Elon Musk, and he's spending trillions to try to get to Mars. We have Mr. Ray Kurzweil, and he's talking about eternal life. He says that we're just a few scientific breakthroughs away from achieving eternal life. And then we had the other day, they inaugurated the first, what is it, gay Toy Story, upper left there, upper right there, okay? And then everybody is using masks out there. If you want to, here in Frankfurt, if you want to go and buy something, you need to wear the mask. The other day, JFG, I was on his program, and he said that, why do I use a mask? Am I bowing down to authority? The issue is not that. The issue is here in Frankfurt, you don't need a mask, and I never wear a mask whenever I can help it. But when you go into a supermarket or you go into a public transportation, like train or whatever, you need to use the mask. Otherwise, they won't let you in. And other places, I think New York, so on, have the same issue. So you have no choice. Either that or you stay fighting against the system, go to jail, and go through all that trouble. I think I don't need all that. So yeah, I don't wear a mask whenever I can help it. But yeah, all this shows to me that we live in very uncertain times, very different times. Uh, any person who's my age or older, I'm going on 68 this year, and I'm sure that a lot of people who are in their 80s, they must be horrified by what they see out there. It's a little different than it was in the 1930s and 1940s for those people who are still around. Anyways, there was a comment. I'm going to start with fan mail here. And this had to do with the extinction theory. By the way, my extinction theory, for those of you who are new, I'm saying that we're the last humans on Earth, okay? And we're the last humans because the global economy is going to collapse, okay? Money will be no more. And people sometimes misinterpret that I'm saying that trade will be no more. There will be no exchange, okay? And you say, well, why won't there be any exchange? Well, there won't be any exchange because hunter-gatherers don't exchange, okay? A lot of these people don't realize that we invented exchange in the Neolithic, maybe, my best guess, maybe 5,000, 6,000, maybe 7,000 years ago, when we went from subsistence agriculture to commercial agriculture. That's when we started exchanging. This guy was a, I don't know, cobbler, and he made shoes, and the other guy liked the shoes that he made, and then he started exchanging things. Until then, it was subsistence agriculture. Before then, it was only hunter gathering. We killed some animal out there, and we lived another day. That's the way it was. So exchange, trade, commerce. That's a that's a new invention of our species. We invented it maybe, I don't know, again, 5, 6, 7,000 years ago at most. Okay, so what is the issue? The issue is that people can't relate to a world without exchange, without trade, without commerce. Okay, and this fellow wrote the following: says money is an efficient system, no doubt about it. I don't dispute that at all. In an exchange between two parties, one side has the money and ability to make loans, and the other side has some value to offer. If we have no money, God waves a wand and all the money disappears, there will still be value. Value will never go away. And, what can I say? Value. Every time I hear that word value, I know I'm talking to a Disneyland economist who has very little understanding of the natural economy. He's never been in the wild or anything like that, you know. No, hunter gatherers, they don't know anything about value. All they know is about food. That's the only thing of value, okay? And just any animal out there, just you pick it at random. Wild animal, the only thing he cares about is food. He doesn't use this notion of value, you know, like tigers don't exchange with lions or lions with hyenas, you know, a gazelle. There's no exchange. Like you give me the gazelle and I'll give you this wildebeest or something. No such monster in the wild. No exchange. They're stealing, yeah. I've seen hyenas steal, especially from weaker animals such as what is it? Cheetahs, because they're smaller animals, and the cheetah just runs away, you know, because the hyena is a bigger animal. So they're stealing and opportunists. That's there, but there's no trade. The only thing you're going to trade is your life if you stick around or fight for it. Okay, and yeah, these people don't understand that. Anyways, why do you think the global economy is going to collapse? Here, I'm going to go real quick through this, a little synthesis here. This is the world population growth rates for people. We are producing fewer and fewer children on the planet. Okay, and that was foreseeable. Okay, that would happen. And since 1963, the last year where we had the highest point, which was at 2.3, I think it was. Yeah, around 2.3. That's dropped to about 1 in this day and age, and it's going to drop to 0 growth rate, right, by mid-century sometime, if everything continues as it is. And why is that important? Because to the economy, because demand is ultimately an issue of population. You have no population, there is no demand. Okay, and people don't always understand that. They think it's a question of quality. If I make a better product, well, people will want that product. And again, that's Disneyland logic. Okay, now we don't care about quality, we don't care about technology, we don't care about any of that. Uh, the issue here is if you don't have people, you will not have demand. In the end, quantity is ultimately dependent on demand. And right now, we're killing demand because we're not having people. We're not producing people. Why aren't we producing people? Because we went from the country to the city. There was a transition. There's a transition still going on in many countries where people are abandoning the farms, especially the big agricultural corporations, and moving to the cities. Okay, because life is better for whatever reasons. And so this migration to the city is leaving the country in the hands of fewer and fewer people. And when you're in the city, you have no kids. City is not a place to have kids. We had kids when we were in the country, not in the city. So that's going on. That's unstoppable. We can't revert that process. Predictable. We know we're going to have fewer and fewer children in the future. We know all this already. Okay, and there's nothing we can do about it. Humans, with all their intelligence, all their technology, they can't fix the population problem. Okay, and some people say, well, it's good that we don't have more population because that way we don't destroy the environment and blah 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 blah. No, we're talking about the economy. The economy is you need people in order to have demand. Period. And here's global GDP. Gives you an idea of since 1980s. It's gone up, and it's in proportion, essentially, to or parallel to the number of people on the planet. We're still growing as far as people population wise, right, on the planet. And that trend more or less mimics that trend, okay? But what's the latest trend? Well, the latest trend you can see in the last few years, 2006, 2018, we've been rather flat on global GDP growth. And for sure, with this coronavirus, it didn't help us at all. It gave us maybe, just maybe, okay, maybe it gave us the coup de grace, the straw that broke the camel's back, so to speak. You know, that's the starting point of now a relatively short period in which our economy will go up and down for sure, but always going lower and lower and lower. Yeah, that's what I think is going to happen. But again, that's my opinion. Okay, only. Um, this is my view of what we can expect as far as global economy. Okay, we're at that point. We're still up there, and pretty soon the economy is just going to go south, going to go down to zero. And what does that mean? It means that nobody will exchange anything because the only thing of value will be food. Okay, that's my take. Take it or leave it. If you have the intuition to understand that, fine. Then you reach your own conclusions. Okay, can't help you any further than that. I can only give you my personal view on this. Okay, the scientific part, which is not my personal view now. That we're talking about science now. Science is objective. All the past species died because of food. They died because of starvation. They died when their ecological pyramid overturned and you had the many chasing the few. Okay? So what died was primary production. Case of the dinosaurs, the most famous one. We can just mention it just as an example. The cycadioids, Williamsonias, and so on. All those forests, those jungles disappeared almost. I showed the graph in past chats. And as they disappear, or those what I call shrinking islands, you know, imagine a jungle and it shrinks. Like in Brazil now, they're doing a lot of slash and burn, so the Amazon jungle is shrinking, and whatever animals are in there, they're caught in this shrinking island. That's more or less what happened to the dinosaurs. And yeah, when that happens, you have fewer species and fewer members within each species. Okay, so it's the ecological pyramid overturning, and that's what's going to happen to man. His ecological pyramid is going to overturn because we produce our primary production. We produce it, and we produce it why? Because of money, because of exchange, because of trade, because of commerce. Okay, so that's the issue. Okay? That's why it's the global economy, I say, that's going to trigger the starvation of man. Most people, others will die for cannibalism or who knows what other killing, murder. There's going to be all kinds of fun stuff at the end of the world. Okay. Okay. So let's get on with the subject matter of today, but it starts out with some comments that were made with respect to my interview with JFG on what was it on Sunday, and we were talking about what is space. Yeah, what is space? In other words, right now we have the mathematical physics version, and that says that space is something. It's a physical object made of particles, okay, um, and an active participant in physical processes. That's the notion that mathematical physics has concluded with. Okay, and the first question is that, or the issue here is that mathematical physics has never defined what an object is, what a thing is, what something is, what an entity is, what a body is. They never defined that. They say, "Oh, you know what a body is. You know what a thing is." No, I don't. Please define what a thing is. And they've never done that. What they do use is the informal version that we use in ordinary speech, which is see and touch. Okay, you touch the table is an object. You see the moon is an object. The problem with that is that you need someone to do the seeing and touching. You need another object. And again, the moon is not an object until the asteroid hits it. That means you need the asteroid for the moon to be an object. And the asteroid's not an object until it hits the moon either. So as long as the asteroid doesn't hit the moon, neither one is an object. They only become objects as soon as one hits the other. That's what they're saying. And that's why you can't use the see-touch criteria, okay, or criterion, right, to define the word object for the purposes of physics, okay? And instead, I propose that we use the word shape. Okay, that's going to bring some nasty debates here. Okay, so let's continue. Here's the first comment. It's related to that. Okay, so we're going to start with the comments. And this fella, he says, I won't read all that, I guess, because he says he's been following me for many years and he likes what I say, and then he proposes something in exchange. And what he proposes is that we got it in reverse, that space is something and the objects are nothing. The atoms are nothing. Atoms are holes, like in Swiss cheese, in a in a something called space. And again, the problem with that, again, is that people don't define what an object is. See, if you define an object as that which has shape, right? What contains this spacey thingy? Okay? What's outside of it? That's where you have a problem with that notion. Okay, and so again, it makes me wonder if these people understand sometimes what I'm saying out there. Okay, another comment along the same lines. Fellow says they go through each other, referring to the ropes or to the threads. I'm not sure which one he was talking about exactly. They don't entangle because touch and see are not properties of these ropes. Okay, ropes. That's right. Yet he explains magnetism, right? Saying that magnets repel because ropes push each other away. What a load of bullshit. And then he says, looks like a one-dimensional concept. Katie says it's BS, yet he does the same shit. Okay, so what's the issue? The issue is an object is not that which you can see or touch. And people don't understand that because they want to bring in the notion of ordinary speech. What's the notion of ordinary speech? It's the see-touch criterion. And that's the one the mathematicians use, and that's what they bring in there. They say, well, if we can see it and touch it, we can go to the lab, we can test it, we can measure it, and that's what an object is to them. And that's not what an object is to Mother Nature. Okay? Mother Nature made her objects her mediators for gravity, for magnetism, light, etc., made them invisible and intangible. And so that means there's no object out there because it's invisible and intangible, and or intangible. We can't see the air. We can touch the air. I touch something, but I can't see it. And there are other gases you can't see either. For example, phosphine. We dealt with these gases in the semiconductor industry, and so you don't see these gases, and they're not made out of atoms. There's nothing there, and so just because you can't see it, it doesn't mean it is not an object. It's not made of something. It's not something. You can touch it, but you can't see it. It's like touching a ghost or whatever, right? An angel. And then the ones that Mother Nature uses, they're untouchable also. They're intangible. And so you can't go to the lab to try to prove their existence. Okay, you can't say there's nothing there because you can't see or touch it, because an object is that which has shape. Not an object is not that which you can touch or see. And that's where the problem comes in. When people bring in this touch-see criteria to deal with something that its only property is shape. Okay? That's going to be the context here. And no, it's not a one-dimensional concept. There's no such thing as a one-dimensional concept because a concept is not a body. And so you can't talk about the one-dimensional, two-dimensional, three-dimensional concept. Love does not have dimensions. Okay? It's a concept, and there's no such thing as one-dimensional love. Maybe in poetry, maybe in ordinary speech, not in physics. And so, no, it's a rope is a physical object. A thread is a physical object. Why? Because they have shape. And if they have shape, all these objects are three-dimensional, all of them. We just can't see them or touch them because that's not the criterion to determine what Mother Nature made specifically intangible and unseeable. Okay, so here's another comment. Along the same lines, if space has no shape, then what is there between two atoms? And he answers with my answer. In other words, he says, distance is separation with a rope. Bill states that in between objects, atoms, is distance, which is a rope. Yeah, good. He answered the question, so what's the problem? He answered the question with my answer. What is he referring to? Well, here's the rope model for those of you who are not familiar with it. Okay, you have two atoms, and they're pumping. Okay, they're doing their quantum jump. And what is a quantum jump? It's just the expansion and contraction of the electron shell around the proton star. Okay? And when it does that, I'm not going to go into the atom right now, but when it does that, it torques the rope that connects any two atoms in the universe. Okay? Any two hydrogen atoms in the universe. So they're pumping, and when they pump, when they expand and contract, they torque the rope. That's light. Okay, so light is mediated by a rope and its torsions along the rope, which we're going to call light. Okay, so that's the model. Okay, let me get myself back in here. See if I can get myself in here. Okay, and so here we compare the quantum model against the rope hypothesis, the atom. Okay, here's the two. The first one is by Mr. Rutherford, which I showed the other day, single electron bead that orbits a nucleus. The only thing Rutherford has to tell us is what is between the two particles. And he says, he answered empty space. That's what's in between there. He doesn't even say field, he just says empty space. And if it's empty space, then the question is what keeps the electron bound to the proton. Under the rope model, here you have a 2D and the 3D version. 2D version, it's you see a star, and 3D version, you see a star. That's what the proton is. It's encapsulated by this shell, which we call the electron shell. Okay, and that shell expands and contracts. By doing so, it torques each one of those ropes that's converging upon our atom. Every atom in the universe provides a rope to our atom, because all atoms are interconnected by what we call electromagnetic ropes. Okay, that's the model. Okay, and so now you see a big picture here of this, and you see why distance is the length of a rope. Under the mathematical physics version, every atom is an independent entity just floating out there, right? And distance is just that separation. It's not even distance, because mathematical physics measures everything and they give you a value. They say so many feet, so many inches. And that's not what distance is. That's distance traveled. What the mathematician has done is unrolled a measuring tape. Under the rope model, distance is simply separation between two atoms. And since all atoms are interconnected by the electromagnetic rope, distance equates exactly to the length of the electromagnetic rope. Okay, so that's what he was referring to, and yeah, that's the answer. Okay, so no problem there, I guess, as long as he understands that. He can then believe or not believe what the proposal is, but at least the important thing is to understand it, not to believe in it. Okay, and here's another comment, and it says a rope cannot be observed. Yeah. Intangible and invisible. Okay, this is similar to stating that the fourth dimension, which is outside our 3D sensory capabilities. Well, no, this has nothing to, there's a difference first. There's a big difference. The difference is a dimension is not a physical object. So it's not that we can't see the fourth dimensions. You cannot see a concept. And the rope is not a concept. A rope anywhere in the universe, the rope that the Klingons have on the other side of the universe, it's a physical object. This is a rope. Okay, this is a rope. Okay, and anywhere in the universe, a rope is a physical object. A tree is a physical object. A table is a physical object. All these are objects. A dimension is not an object. It's a concept. So you can't say you're going to try to see a dimension, the fourth dimension, or third dimension. You can't even see the third dimension, because you don't see dimensions, you see objects. Okay, so that's the problem there. Okay, but then yes, rope cannot be observed, first because we don't use observers in science. Okay, an object has shape all on its own without any observer. The moon had shape before any of us was born. Okay, we weren't there to observe it, and so we don't need observers in science. We just need to identify the objects. Okay, that's the first one. The other thing is that ropes the electromagnetic. This rope is tangible, and it's also seeable. You can see it. It's not invisible, and it is visible, and it's tangible. Okay, but this is just an example of shape, not of see touch. This is an analogy for shape of what Mother Nature uses between two atoms to do light, to do gravity as well, as we've seen in previous videos. So the only property that this represents is shape, not see touch. And when people see this, they say, "Oh, how come can't touch your rope?" Well, because that's the wrong criterion. How come I can't see it? Because of the same thing. That's the wrong criteria that you're applying. Okay. And okay, so yeah, no tangibility, no visibility, none of that. And yeah, what you have to do is define these words. In fact, let me put this fellow back up there. There it is. So he says, a rope cannot be observed. And do you see a provision for observing in the definition of something? Something is that which has shape, okay? Those are the synonyms there. And nothing is its exact opposite, that which doesn't have shape. These two words are antonyms, okay? And so what this tells us is that we can now use them consistently, okay? We can use them consistently in any dissertation because, one is the opposite of the other. And so you can say, okay, what is something? Well, something that which has shape. What is nothing? That which doesn't have shape. Very straightforward, very kindergartenish. You can't understand that, I don't know. Okay? So nothing, otherwise known as space, otherwise known as vacuum, not the quantum vacuum. We're talking about a genuine, scientific vacuum, okay, is nothing. And nothing is that which doesn't have shape. All the objects that are within space, we call it within space for lack of a better term, they're really what the objects are all atoms, and all these atoms have location with respect to other atoms, not with respect to space, because there is no such thing as space. Okay, atoms only have a relationship to other atoms. They only interact with other atoms. They have gravity with respect to other atoms. They send light to other atoms. None of that has anything to do with space, because there is no physical object called space. Space is nothing, and nothing is that which has no shape. So all that black stuff you see between the earth and the moon, that's nothing. There's nothing there. Okay? And so it's when these mathematicians talk about empty space, you wonder what they're talking about. And some people have suggested, well, they're saying that empty space is just a lower volume of particles. Like if you vacuum, remove stuff out of a chamber, and now you have not complete empty space, but what you have is a reduced number of particles in there. They call that empty space. Some people say that. No, we don't have a notion of what empty space is, because they never defined the word nothing. And that's what you got to define. They never done that in 10,000 years. Okay, here's another comment. Always getting to the subject matter today, and this is: space is then infinite, as there is nothing that lies beyond it. Okay, nothing. We have an infinite, and nothing's beyond this infinite. The first problem there is that infinite is an adjective, and the word infinite in physics can only be used with respect to objects, and you can't say an infinite object because all objects are finite. So the word infinite is an irrational term any way you look at it. We can't use the word infinite for anything. It's an irrational term. It was really created for mathematics, because they would talk about infinite numbers, that sort of thing. That comes at least from the Greeks, if not earlier. Okay, so when you talk about infinity, you're talking about counting incessantly. And they call that infinite numbers, or infinity. Okay, well, no one's ever been to infinity, because nobody's ever counted forever to find out what the last number is. And of course, there is no such monster. So that's what they mean by infinity. No, we can't use the word infinite in science. And anyone who uses it to make his case doesn't understand that, is not familiar with the argument. Okay. So yeah, all objects are finite, so there is no such thing as an infinite object. And if space is an object, you cannot say that this object is infinite. And if it's not an object, if it's a concept, you can't talk about an infinite concept. What are we talking about here? Endless love? I mean, what is this infinite concept? Well, infinite intelligence? I don't know. It can be a non-object. Absolutely not. That is infinite. Again, you can't have concepts that are infinite. There's only two types of terms: objects and concept. Those are the categories of terms that for every word in the dictionary can be put under one or the other category. And I think I've got it here. Let's see. All words in the dictionary can be divided into two categories: objects and concepts. Objects we point to, concepts we define. We can point to objects because they have shape. Concepts, no concept has shape. So there's nothing to point to. And there's your definition of concept: a word that invokes or embodies two objects or two words treated as objects. For example, the word object. The word object requires two thingies, a contrast, okay? And what you have is the shape and something that gives contrast to that shape. And we treat that contrast, that backdrop, that what's in the background that gives it shape, we treat it as if it were an object. That's why universe consists of objects, right? Matter, and space. It's a word, it's a concept. We call it universe, and it has these two members, these two components: objects, which have shape, matter, and space, which we treat as if it were a physical object, giving background or contour to the atoms. That's what exists. That's what we have out there. That's the word universe. Okay. Okay. Anyways, so yeah, the issue is defining, and here we have the notion that people have. Okay, also for this fellow. Okay, and that's typically what we identify with space, or a lot of people identify with space. They say, look, space is that stuff here in the center, that all those white things, those particles. Always identified also with the ether. Okay, because they say the ether is space or is contained within space. And those are two different arguments, okay? But either way, what they're saying is that there's some black stuff that gives contour to each one of those particles. And so the issue is not identifying the white stuff. We can all deal with that. The question is, what's the black stuff that gives shape to each particle? That's the one you need to identify. If you can't identify that, you've got nothing. And then we have infinite space. Okay, here's the infinite space version. Okay, it never ends. It ends in here because in my show here because I could not make it infinite for you. Sorry. So I had to put a little frame around it. Okay, but you have to think of this as infinite. So what do you mean infinite? You mean this just extends? What is it? A question of running to the edge of the universe, or what? What do you mean infinite space? And yeah, that's the notion they have. This is the so-called infinite space that people have in their minds. And the question is, how many particles are there? And they say, well, it's an infinite number of particles. Okay, that's the notion these people have. And and there's two notions there as well, by the way. Okay, and the Greeks had that problem as well. One is, are we counting the number of particles to infinity until you die, or whichever comes first? Or are we talking about the whole shebang being extended eternally or incessantly or whatever? So these are two different notions: number of particles and the whole shebang being extended, what they call infinitely. And again, you can't have that because all objects are finite. Okay, so you can't talk about an infinite object because you don't even know if it's an object, if it's infinite, if you can't see its shape. You got to see it from a bird's eye perspective. And then the number of particles, more or less the same thing, because it's got to have a shape. And if it has shape, it has borders. And if it has borders, whatever's in there, it's got to be finite number of particles. Okay, under the rope model, there's only a single thread in the entire universe. That's all there is. This converts to atoms and ropes, ropes and atoms all around. And so the amount of matter is constant because there's a single thread in floating out there, what you could say in space, in nothingness. Okay, so in other words, the atoms float with respect to each other. That's what I'm really trying to say. Okay, so what is an object? Let's go back to that so we can get back to the word shape. Okay, that's what we're trying to see today. This is what an object is not. An object is not that which you can see. It's not what you can touch. It's not mass. It's not volume. It's not motion. It's not made of what we call mereology. Okay, you can't say that air is a bunch of particles. That's not the definition of an object. If we're going to say that air is an object, okay, a thing, and a lot of people have problems with that word object there. They say, what do you mean air is an object? I thought a table was an object. Yeah, but there's no difference between table and air. No difference whatsoever. Air is a bunch of molecules and atoms, right? And that's what a table is. So are you going to say, oh, this table is 3 trillion atoms or whatever, 3 trillion molecules? Is that what a table is? No, a table is what you point to. And you can point to the air as well. Okay, you can point to the air, especially the air around the earth. It forms a shell around the earth. That's the shape of air. And if you don't like that, well, you can tell your friend the astronaut to take a little balloon out there in the middle of space, okay, with air in it, pop it. And if you could color code that air so that you could see it, you would see a blob. And that blob is made out of atoms. So air is an object because air is made of molecules and atoms, not because of that, but because it has shape. When you pop the balloon and then you have the blob out there, that blob has shape. What is the shape of it? That's not the question. The question is, does it have shape? We don't ask, what is the shape of energy? We ask, does energy have shape? Does mass have shape? That's the issue. Okay, so it's a yes or no type of question. Okay, again, we don't use a temporal notion. Seeing it through parts. Again, mereology. It can't be an object is not that which is the subject of a sentence. It's not any noun that you can think of. The word motion, the word orbit, the word itinerary. None of those qualify as nouns for the purposes of physics. We have to distinguish the language here. We have a new language and people have to be in tune with the language if they want to understand, okay? And so what is a noun in ordinary speech is not a noun in rational science. Why? Because you cannot introduce those words which are concepts in ordinary speech and introduce them as nouns in physics. In physics, only objects qualify as nouns. You can't say the mass, a field, or the wave. You can't say that because those are all concepts. And so you can't use those words as physical objects. You can't treat them as physical objects. They cannot serve as nouns for the purposes of physics. You're bringing ordinary speech into science when you do that. And a lot of people say, well, Bill, you're doing a lot of semantics. I want to do the physics. Science is about explaining phenomena, physical phenomena. You need to explain the mechanism. If you're going to explain the mechanism, you need objects. You have to be able to distinguish between an object and a concept, between what has shape and what does not have shape. And if you can't do that, well, you got to start there. That's your kindergarten work, okay? You got to go through kindergarten. An object is not that which has color. An object is not that which exists. A lot of people confuse an object with that which exists. And here I like to show this, Mr. Hume and Mr. Kant, whatever. Hume said, and this was what, 1739, the idea of existence then is the very same with the idea of what we conceive to be existent, to reflect on anything simply, and to reflect on it as existent are nothing different from each other. That idea, when conjoined with the idea of an object, makes no addition to it. he couldn't tell the difference between an object that exists and one that doesn't. So he said object and exist are the same words, are synonyms. And Kant, a few years later, said the same thing. Nothing is really added to it if I add that the thing exists. Okay? And yeah, to this day, people who I guess have not read either one of these two so-called philosophers, they make the same error. They think that an object is that which exists, which you can touch, which you can see. That's the notion from ordinary speech. And we're debunking all that. We're saying, look, if you come into physics, into genuine physics, not what the mathematical physicists do, you have to have a different notion. You have to separate the word exist from the word object. These are two different words. One has very little to do with the other one, and the difference is that exists. In order to exist, you must have location. So it's an object that has location. That's what exist means. There are objects that don't exist. A plane, for example, such as a square or a triangle. That's an object for the purposes of physics because it qualifies with shape. It has shape, okay? But it's an object that doesn't exist because what exists is the pencil or the ink, right? And the paper, but not the triangle, okay? Triangles don't exist. So here you have an object that doesn't exist. Superman doesn't exist. He's an object. He has shape, but he doesn't exist because at least the cartoon character where he's two-dimensional. Snow White, she doesn't exist either, okay? And they're not concepts. They're objects because they have shape. That's different than love. Love doesn't have shape, and people don't always capture these notions. Too swift for them, okay? So we come down to what Mr. Let me get this out of here. Come down to what Mr. JF had a problem with, and he questioned me about it. He said shape, and so he asked me, well, what do you mean by shape? And at the end of his program, he made a comment. He says, he was disappointed that I did not define the word shape. So what's my answer to that? And that's what the show today is about, really, the key point. And here are my arguments against it, okay, in a nutshell, okay. And so the first one is we have the devil's advocate, okay, and these are extreme devil's advocates. What they have happened to them, they lost a war, and so they're looking for vengeance. They're not constructive, they're destructive. And I'm going to go over that in a second here. There are other people who genuinely want to know, what the arguments are because they're not aware of what the arguments are. Why aren't you defining shape, Bill? I mean, you said that an object is that which has shape. Now you're not going to tell us what shape is. What's the reason? Why are you doing that? Okay, and the answer to that is it's irrelevant. That's going to be the argument. Okay, I'm going to get that in a second here. If we do not define shape, if for whatever reason we happen not to be able to define the word shape, does that mean we go to the default, which is the mathematical physics version, or the version of ordinary speech? Are we going to say that, then we're going to go with see touch, and that means we're not even going to define see and touch? I mean, what if I ask you, what do you mean by see? What do you mean by touch? And what if I badger you to and play my role as devil's advocate and ask you to define those terms? Could you define them? But see, when you try to debunk the word shape as the criterion for defining the word object, what you're really doing is saying, well, see, you couldn't define it, Bill, or you didn't want to define it, so I'm going back to see touch. That's what you're saying in essence. You're going back to see touch because that is the default, and that's the default we need to destroy. We need to debunk that notion. There's the issue of 2D versus 3D, shape versus form. A lot of people have questions with that. And then the other issue, the final issue, will be that shape is a property. It's an attribute of an object. So the words shape and object are not synonyms, okay? An object has shape. It's the universal property of all objects. Okay, let's go with the first one, devil's advocate. what happens? You go in there and you define um, the word object, okay? And you say it's that which has shape. And so you throw the ball to the other guy and you say, okay, you define object. What's your definition? What's the alternative? And so this is where it all starts. And the first thing we say is that we don't define every word in physics in science. We just define the crucial words. Okay, that's the first thing we tell this person. Okay, the devil's advocate. We don't define just to please the devil's advocate. And the issue is not definitions for the sake of defining. The issue is criterion or criteria. That's the issue before us. What is the criteria that we're going to use to define the word object for the purposes of physics? And so when you say shape, and the other guy says, well, what do you propose in exchange? And so they come up with all these words that I came up with earlier. They say, well, it's that which we can touch. It's that which we can see. So you show the error of his ways. Okay, you say, well, to touch, you need another object, and to see, you need another object. So again, the moon is not an object until the asteroid hits it, and vice versa. And until they hit each other, they're not objects. Obviously, you don't need to have an interaction with two objects to define one object. So that's where all these notions die. Is it that which has mass? Mass is a dynamic concept. Whether you count atoms, quantity of matter, or whether you accelerate it under special relativity and go with relativistic mass, you're talking about motion. And motion is a word we define after we define the word object. Only objects can move. So you have to define the word object before you define the word motion. Or the word exists for that matter, and so on and so forth. Distance, whatever. You need to define the word object. And you can't do physics without objects, so you must define the word object. So I had a long run discussion with a fellow that goes by the moniker Dr. Dave. And and this fella, he badgered me for several weeks on the word shape. And why did he do that? Because he could not define the word object. So I badgered him on the word object right back to him, and he never was able to define the word object. In fact, he ended up saying that we do not need to define the word object for the purposes of physics. Now I say, hold it. What do you mean you don't need to define the word object? We can't do physics without objects. And that's where these people say, well, no, physics is not about mechanisms. Essentially, that's what they're saying. It's not about causes. Physics is about math, about making equations. Science essentially is a process of what? It's a process of discovery. You spend the rest of eternity just discovering and never finding. That's their notion of science. And so all they need to do is describe. And they can describe without having objects. They can use point particles or whatever they want to fit in there. Okay? And so we don't have a physical interpretation. We don't have a mechanism of how this universe works because these people don't know what physics is. They have a different notion of physics, which is math, which is measurement, which is developing technology. And that's their notion of physics, of science. And so we have a problem because we're not communicating. Okay, because we start out with different notions or definitions of what science and what physics are. Okay, that's where it starts. And so he said that he didn't think that he needed to define the word object. So that's his answer to it because, when you put them against the wall and say, well, why do these people give physical interpretations? They give physical interpretations to their equations. Why do that? If they stayed within math and do whatever they want, they invent words, whatever, I don't care. But it's when they bring these words such as energy and mass and field into physics, because they're trying to give a physical interpretation to their equations to show you that they know and that their equations give them some insight into how this universe works. That's where we have the problem. We have a problem not with math. We have a problem with math physics, mathematical physics. That's where we have a problem. Because these people are bringing their equations into physics and saying, look, we can tell you how this universe works. And you say, you can't. And they say, yeah, we can. See, the other day I mentioned Earth dragging space around. How can you drag space around if space is nothing? And he said, no, space is something. Well, then we need to define these terms to find out what you mean by nothing or by something. That's one issue. The other one is you got to explain why the Earth doesn't fly away out of the solar system, for example, right? And they say time is warped. That's why Earth rolls around warped time. That's what they're telling you. So what do you mean warped time? Time is not a physical object. Well, we don't understand it either, but that's what our equations tell us. And that's what we proved with our experiments. So we have a problem. We have a problem because they're giving you a physical interpretation. In order to give you a physical interpretation, they have to introduce objects. They have to introduce the Earth. They have to introduce the sun. So they have to tell us what those objects are. What is an object? And then they turn concepts such as time and space into physical objects in order to accomplish their, to be in consistent with their equations and with their physical interpretations. And so now we have a problem because now we need to define these terms. And to say that he doesn't need to define the word object is only a cop-out. And why? Because he wants to harp on the word shape because he's beaten. And at that point, he's got to try to get back at you. It's just vengeance. That's all it is. There's nothing constructive. It's just, he wants to show you that no matter how you twist and turn it, you're going to need words to define the word shape. And then he's going to say, well, what do you mean by this other word? And what do you mean by that other word? And then you're going to you have this monster where you have more and more words always to define. It's, there we can use the word infinite for sure. It's to infinity. So here's one argument against it. Let me show it to you. Let's see if I can get it here. There it is. What is an object? Well, an object is that which has shape, right? And so the question is, why didn't he ask what the word that means, or what the word which means, or what the word has mean? Why did he harp on the word shape? I mean, is it easier to define the word which, for example, or the word has? Do you understand? Can you define those two terms real precisely, very scientifically? Why did he harp on the word shape? In other words, we don't define, again, words for the sake of pleasing the devil's advocate. We define those words that are necessary, where there's a problem, where there's a clash. And in the case of the criterion that we use to define the word object, these people want to introduce see and touch, and we say no, it's not see and touch, it's shape. So now we have something to compare. We have shape against see touch, or against motion, or against mass, or against volume, or against noun, just any noun, any subject of a sentence. Now we have a comparison. So we don't have to define the word shape. What we need to do is know the difference, or understand the difference between shape and motion. We have to understand the difference between shape and mass. We have to understand the difference between shape and see touch. Because we're choosing a criterion for the word object for the purposes of physics. That's the issue before us, not the issue of shape. And so when a person harps on the word shape, could be one of those two groups. Could be a devil's advocate, which is the majority of them. Could be a group of people who just don't understand why we're not defining the word shape. And I'm telling you why. We don't define the word shape because it's irrelevant. The issue is comparing shape against what we have today, which is see touch. That's the main issue. Okay? And that's what you need to understand. And to harp on the word shape and shape and shape, all you're doing is moving from that second category of casual observers or questioners or inquirers to the devil's advocate group, because you're not understanding the context. The context is not that we want to bypass the word shape. The context is that we need to compare shape against mass, see, touch. That's the issue before us. And if we do not define the word object today, we can't leave the conference room until we do. Then what happens if we don't define the word shape? We have the default. What's the default? See, touch. That's what people are using. They can't use that in physics, especially with stuff like the rope hypothesis. The rope hypothesis says the rope has shape. It's an object. You can talk about this object, binding two atoms. My fist being here, two atoms. You can talk about that because you got a physical object between them. Why can't you touch? Why can't you see the rope? Because that's not the criterion for determining what an object is. But you can't say that the two atoms are bound by love. You cannot say they're bound by a wave. You cannot say that they're bound by what, a field, because those are all concepts. So you can't use a concept as a physical mediator, as a cause, as a mechanism. That's the issue. Okay? So why is it irrelevant? It's irrelevant because first, we don't define words for the sake of defining words. We just define the critical words. The word object is a critical word. It's the first word that everybody's got to define in physics. Why? Because you can't do physics without objects. And physics is not math. Physics is not technology. Physics is explaining a mechanism. Mechanisms can only be done with objects. You can't do a mechanism with concepts such as field, force, time, mass, or energy. That's the issue. And so you can't say, I'm going to do this with energy. No way. Not in physics. Maybe in the religion of mathematical physics, but not in physics. Okay? So that's why it's irrelevant. It's taking the conversation on a tangent and saying, look, I'm going to harp on the word shape until you define it. Otherwise, I'm not going to accept your definition. Okay, you don't accept my definition. What are you going to put in instead? We need to define the word object. What are you going to put in there? You're going to put motion? Are you going to put exist? Are you going to put, see, touch? That's the issue. The issue is the word object, not the word shape. And here I have a little summary of that issue as well. These are the key words we need to have for the purposes of physics, okay? And they're in dark blue there on the right-hand side. You see the word object, the word distance, the word location, motion, exist, concept, and matter. Those are the foundations of physics, and you must keep that order. You can't define the word motion before you define the word object, not in physics. You can't define the word distance before you define the word object because you need two objects to define distance, okay, and so on down the line. So they have to be, those are the foundations, and they have to be in that order, okay? And do you see the word shape in there in any of those dark blue words? No, because shape is not a key word, okay? Shape simply is a criterion to compare against see and touch. That's the main point. But you can compare it against mass. You can compare it against any of the other words that they use. Okay. Okay. Another issue. Let me get this back in here. Another issue here is 2D versus 3D. Some people say, well, an object is that which is 3D. That's in ordinary speech. You're bringing the notions of ordinary speech into science, into physics. You can't do that. In science and physics, it's black or white. There are no 3, 4, 5 categories. There's only black, white, on and off, yes or no. Okay? It's got to be black and white so that people see the difference. You can't, muddle it by saying, oh, we've got these 10 different categories. No, that's okay for philosophers. They know no better. Okay, that's fine. No, in physics, it's got to be black and white, on and off, on or off, yes or no. Okay, and so what's interesting in Spanish, we don't have the word shape. We use the word form for everything, and probably in other languages as well. So there is no word for shape. Shape is typically used as 2D, two-dimensional in ordinary speech and mathematics, and form is usually used for 3D. That's in ordinary speech. In other words, in religion. In physics, there's only shape and no shape. Shape and form are perfect synonyms. It's an outline, it's a contrast, call it whatever you want. That's all shape is. That's all form is, okay? So don't tell me that, oh, but you're talking about 2D and 3D. Nah, we don't get into any of that. Okay, form, shape are synonyms, and so there is no such thing as 2D and 3D shape. When we talk about 3D shapes, okay, we typically talk about objects that exist. Okay, so if you have a table which you drew, okay, and it's on a 2D platform, in other words, on a sheet of paper, and you just drew it, that's a table. You point to it and say table. So you gave it the word table to designate it. Well, that's not the same as the 3D table where you eat your coffee, drink your coffee every morning or eat your breakfast. Okay. That's a different kind of table than the one you drew. They're both tables, but this is a 2D table. It doesn't exist. And this is a 3D table, and that does exist. Okay. And what's the difference between them? The 3D table has location. The table has location with respect to the remaining matter in the universe. Okay, so that's where the word exist comes in, with 3D shapes that exist, not with 3D shapes that don't exist. The shape that the table I'm imagining, that's a table too. Okay, I'm just imagining, I'm dreaming about it, right? That's a table. And if I dream of a tree, that's a tree. What did you dream about last night, Bill? I dreamt about a tree and the apple that fell on Newton's head. Okay, and the apple was 3D, Newton was 3D, and the table and the tree was 3D in my mind. Okay, but they don't exist. And a cube, a perfect cube, ideal cube, it's 3D conceptually, right? But it doesn't exist either. Okay, so there are 3D objects that don't exist. Most objects we refer to do exist. And the final point here is that shape is a property of an object. So an object and shape, yeah, are not synonyms, not perfect synonyms. Okay, what we have here, object is a category of words. Okay, every word in the dictionary again can be divided between objects and concepts. Objects, those which have shape. Concepts, those which don't have shape, among other things, but the definition is it's a relation between two objects. That's what a concept is. Okay, and so a relation has no shape. Okay, and you need an observer. Yeah, there you need an observer to tell me, what the relation is. So there are only two categories of words. If it has shape, it falls under objects. Okay, and shape, as well as the word object for that matter. Object is a concept, and so is the word shape. It's a concept. But shape is a property of objects. Okay, shape is the universal property of objects. So they're not perfect synonyms. Okay, it's like saying all these objects have the color red. Well, red is not a physical object. Okay, red is a qualifier of these objects. It's something they have in common. It's a property, an attribute, and shape is more or less like that. Shape only tells you what property all objects have. Okay, and that's what this word is used for. Okay, so again, we don't define just to please the devil's advocate. We don't define every word in existence. We just define those that make or break our theories and those that we need to define to give our dissertation. And the first word you need to define in physics is the word object, because you can't do physics without objects, because physics is not about math, it's not about developing gadgets, it's not about technology, it's not about measuring. Physics is about explaining how Mother Nature does, especially her invisible stuff. We know all the visible stuff. We know how a pulley works. We know how the window broke. That was that brick someone threw through the window. And, those are physical objects. Those we can see. And so we say, okay, I understood how the window broke. I know how the pulley went up because we see all the objects. Where we have trouble is understanding how two magnets, one magnet attracts another. We have a problem understanding, gravity. We let go of the pen, it falls to the floor. Why did it go to the floor? Because we can't see the mediators. That's the only issue. And so all you got to do is, since you can't see or touch them, you can't go to the lab to prove to yourself whatever gravity is. No, the only way is to sit back and visualize what came in contact with a pen, or how two magnets could possibly be attracting to each other, and when you turn them around, they reject each other. Have south versus south in one case, north versus south in the other case. So you need to visualize the physical mediators Mother Nature uses. Okay, that's the issue. Okay, with that, I'll see you, on Sunday, and I hope everybody stays safe and don't catch the virus. Bye-bye, we'll see you.